Now I'll go ahead and install the ESP8266 controller board on top of the shield or expansion board for the servos, as shown on this picture here. This is super simple step. I'll start by cutting the anti-static protective back for the board. Take out the board and take a look at it. So this appears to be a traditional ESP8266 NodeMCU type of board from what I can see, with the reset and boot buttons, except this one is manufactured by Acebott, so it's one of their own clones. It seems to be nice and clean, no solder flux on it. The boards are kind of strange matte type of mask. I haven't seen other boards like this. Looks quite interesting, so they probably use their own technology for that. Now I have to figure out the orientation. According to the picture, it should be oriented with this controller, the ESP8266 controller with its antenna, opposite to the switch, and this connector should be on the same side as the switch, which I presume is on-off switch. So we place the controller here and make sure all the pins are aligned, of course on both sides, and press it in place. Looks nice. So unlike other ESP8266 NodeMCUs, this one, however, has been upgraded to have USB-C, which I really like. So that's it for this step. Let me double confirm that I place the controller exactly the right way. You have to be very careful. So this connector has to be on the same side as this switch, and this controller here, the 8266, together with its antenna, the Wi-Fi antenna, should be the side opposite to the switch. As long as you follow this and align all pins, it should work quite well and easy. So now this step of the assembly is also completed, and the robot is taking more and more its final shape.